Hey guys, welcome back to another video. Today we're going to be looking at a few chemistry hacks that I thought would help you in your chemistry revision. So this is pretty similar to the videos that I've released in the past few weeks, which are like how to productively study geography and history. Except this isn't really how to productively study, but it's just hacks and tips that can really help you, especially in your exam. So this is part one. Yes, you heard that right. This is going to be part one of a three-part series. And in each video I'm going to talk about a separate subject. So in the first video today we're going to be looking at chemical equations and chemical reactions. In the next video we're going to be looking at acids, bases, and salts. And in the last video we'll be looking at metals and non-metals. So now without any further, let's go look at some chemistry hacks. Okay, so the first hack is, one of the challenges in chemistry, especially in the first chapter, is it's hard to remember the color of the precipitate that's formed in precipitate reactions or double displacement reactions. And the easy way to determine the color is this. Any compound that contains iodide would create a yellow precipitate, and any compound that contains barium would create a white precipitate. And in the textbook or even in the exam, you'll only get questions on double displacement reactions that contain these elements. So you need to know that it's either going to be yellow or white. And we can look at our examples here. Sodium sulfate plus barium chloride gives rise to barium sulfate plus sodium chloride. And so the precipitate would be barium sulfate, and since it contains barium, the color would be white. And similarly, lead nitrate plus potassium iodide gives rise to lead iodide plus potassium nitrate. And since the precipitate contains lead, it would be yellow and gold. So that's an easy way to remember the color of precipitates. Next, in redox reactions or oxidation and reduction reactions, it's really confusing, or at least for me, to remember which element plays the role of what agent. So which element is getting reduced and which element is getting oxidized. What is the reducing agent? What is the oxidizing agent? It seems so confusing. And so to combat that, or to deter that, I have this simple hack. So let's look at a few examples. So copper oxide plus hydrogen produces copper plus water, H2O. And zinc oxide plus carbon gives rise to zinc plus carbon dioxide. And finally, manganese oxide plus hydrochloric acid gives rise to manganese chloride plus water plus chloride. So obviously the thing that's common here is the presence of oxidation and reduction. And we already know that the substance that gains oxygen is being oxidized, and the substance that loses oxygen or gains hydrogen would be reduced. So here we can easily find out which substance is being oxidized and reduced. For example, in copper oxide plus hydrogen, if we look at the products here, copper is being reduced and hydrogen is being oxidized, or H2O is being oxidized. And remember that you always have to refer to the substance that's being oxidized or reduced based on the products. So it would be wrong for us to say that copper oxide is being reduced. We have to say that copper is being reduced. And similarly, in zinc oxide plus carbon, we know that zinc is being reduced and carbon is being oxidized. And finally, in this last one, manganese is being reduced and hydrogen is being oxidized. So now, which one is the reducing agent and which one is the oxidizing agent? Here's an easy hack. The substance that's being oxidized, or which gains oxygen, is the reducing agent. And vice versa, the substance that's being reduced is the oxidizing agent. So coming back to our examples here, copper oxide plus hydrogen. So here, copper is being reduced. That means copper is the oxidizing agent. And hydrogen is being oxidized, so hydrogen is the reducing agent. And we know this because hydrogen is reducing copper oxide. And copper oxide is oxidizing hydrogen, or copper is oxidizing hydrogen. And the same applies here. So since zinc is being reduced, zinc is the oxidizing agent, and carbon is being oxidized, so carbon is the reducing agent. And now similarly, manganese oxide has been reduced, so manganese is the reducing. Manganese is being reduced, so manganese is the oxidizing agent, and hydrogen is being oxidized, so hydrogen is the reducing agent. And now let's look at a question that was actually in the sample paper released by the board. And we have a similar question right there. So let's take a quick look at that. So as you can see here in this question, we have a reaction, copper sulfate plus iron gives rise to copper plus iron sulfate. And we know that this is a displacement reaction because iron, which is the more reactive element, is displacing copper from its compound. So it's asking us to which option in the given table correctly represents the substance oxidized and the reducing agent. So here we already know that it's asking for the substance oxidized. So we know that the substance that gains oxygen would be the oxidized substance. So in this case, iron is gaining oxygen here. So iron is a substance being oxidized. And what is the reducing agent? We also know that the substance that's oxidized is the reducing agent. So the reducing agent is also iron. So the correct answer would be option A, and it's confirmed correct because we've got the answer to it. Yeah. So the next hack is related to corrosion. And we know that corrosion is the tarnishing or formation of a light oxide layer on some metals when they're exposed to oxygen or moisture. So different elements form different color oxides, and it could be hard for some people to remember it. Even me, I always have to look back at the textbook to see which element creates which color oxide. But here's a simple hack. So iron, when it's oxidized, we already know it creates ferric oxide or rust, Fe2O3. And the color of that is reddish brown. And this is almost a very widely known reaction, formation of rust, and the color of rust. But an easy way to remember it is rust starts with R, and so the color of rust is red. And the next, silver, when it's oxidized, it forms a thin black layer. And this isn't very clear, but it's just easy to remember silver as black. And finally, the easiest one to remember is copper, because when copper is oxidized, it turns green. And so to illustrate that, we have a simple example that you should always keep in mind, which is the Statue of Liberty. So when France gifted Statue of Liberty to the US, it was a copper statue. So obviously copper is naturally a golden brown in color. But since the Statue of Liberty was located near the harbor, so obviously there's salt and moisture from the surroundings. So over time it turned green, and that's the Statue of Liberty that we see today. So the easiest example to remember that copper oxide color or the corrosion of copper would be the Statue of Liberty example. So next, rancidity. There's a lot of prevention techniques. If you don't remember, rancidity is the oxidization of fats and oils present in some processed foods. And so if something turns rancid, then it creates a bad odor and bad taste. So it only takes place in processed foods that contain fats and oils. So chips, any baked goods, or any food like that. And so companies use a lot of techniques to prevent this rancidity. And we can remember these with household examples. So chips. Chip bags are flushed with nitrogen gas to ensure that they don't turn rancid because they contain fat and oil. And similarly, if we have any kitchen leftovers, we usually keep them in the fridge. So another technique to prevent rancidity is refrigeration. And also using antioxidants, which are present in vegetables. They prevent the food from getting rancid as well. So these are a few, and also the last one is keeping the food item in airtight containers to prevent oxygen. So chip bags are filled with nitrogen. You can refrigerate the food. You can add antioxidants, or you can just keep it in airtight containers. So here's a small hack. So if you ever open a bag of chips and you actually want to save it, then keep it in an airtight container, because if you don't, then it usually turns very bad. And finally, the reactivity series, which is probably the hardest thing ever to learn. So obviously there's a lot of these mnemonics on the internet, but this is the one that I found which was most catchy and easy to remember. So please stop calling me a careless zebra. Instead, try learning how copper saves gold. So based on the reactivity series here, we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, silver, gold, and from most reactive to least reactive. So please, potassium, stop sodium, calling calcium, me magnesium, A aluminum. And remember that carbon and hydrogen are added to the reactivity series, even though they're non-metals, because just for the sake of comparison. So please stop calling me a careless zebra. A for aluminum, careless carbon, zebra zinc, instead iron, try tin, learning lead, how hydrogen, copper, copper, saves, silver, gold, gold. So please stop calling me a careless zebra, instead try learning how copper saves gold. So to remember these, instead of remembering all the elements, we already know most of the elements based on their first letter. Especially these few elements right here are the most important, and they're present in all the compounds that we're learning about throughout this entire year. So we already know most of these element names by heart. And so it's easier to accompany the elements in order with an easy sentence with the language that we commonly use. So this is one of the best mnemonics I found for memorizing the reactivity series. And if you have any others, then feel free to let me know in the comments. So that concludes part 1 of this 3-part series. Stay tuned for next week's video, which will be chemistry hacks in the chapter acids, bases, and salts. As usual, don't forget to subscribe, like, and share. And until the next video, this is the Unconventional Chapter signing off. Peace.